Hi, my name's Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. Today, I've got one of our newest applications engineers, Benjamin Ash, and together we're going to install some strain gauges that we'd like to introduce you to. Now, these strain gauges are a new product for us. These are our C5K series gauges. And one of the unique things about it is that this new C5K series strain gauge, we can build these up to 5,000 ohms in resistance. And what we're going to do is we're going to install a strain gauge, these C5Ks. We're going to install one 350 ohm strain gauge and then one 5,000 ohm strain gauge. And then we'll go through the process of testing and look at the differences between the two of them. You may find in your application that it makes a lot of sense for you to move to the higher resistance gauge for some technical reasons that we'll talk a little bit about later. But for now, we want to get these strain gauges installed, and I've got a couple of example beams that we're going to try to create. When you look closely at these two strain gauges, you'll notice they look just about identical from the eye. But the one that's on the left side, that one is a 350, and the one on the right side, that one is a 5,000 ohm. So today we're going to install a couple of these gauges, and then later we're going to wire them into some electronics, and we'll look at the differences comparing the advantages and disadvantages of the 5,000 versus the 350 ohm gauge. But for now, we're going to get started with the installation. So Ben, here are the two packs of strain gauges. These come in a package of 10 pieces per pack. As you look at them, basically the gauges look the same, so it's important for you to document which package of strain gauge is the 5,000 ohm and which package of strain gauges are the 350 ohms. Now, along with the gauges, we're also going to install the gauges onto some aluminum beams, and we're also going to use some fiberglass, and we'll use these in our testing, again, to compare the differences between the 350 and the 5,000. We're also going to use the M-Bond 200, which is our most popular adhesive system for stress analysis testing, and Ben will show us how to do that. And I guess without any further delays, why don't we go ahead and get started. Okay, so the first part of this gauge installation process for these C5K gauges is going to be to prep the surface and get it ready for bonding. And we're going to start with the 2024 T4 aluminum beam. So the first thing I want Ben to do is take a gauze pad and fold it, and then take the can of CSM3 and spray that directly into the gauze pad, and then just wipe off both surfaces of the beam. Basically, these beams have been run through our machine shop. They've been processed some, so they could have some oils on it. Oils from the machining process, or it could be oils just from handling off your hands. So basically, we want to wipe off the surfaces and just try to degrease it because our next step is to abrade it. And this time we're going to use the 320 grit silicon carbide paper to abrade. And where we want to abrade is in the area where the gauge is going to be installed. So if you were to look on the sides of the beam, and probably this is a good time to point this out, you've got some scribe marks on the sides, and you got one set that's about 2 inches away from the end that Ben was showing, and that's where we're going to install the gauges. So we're going to clean that area down on that end, again about maybe a 2 to 3 inch long area. So 320 grit paper, sand back and forth about 10 to 12 strokes, and that's really enough. Then you take that paper and you can throw it away. Now the next step, we're also going to abrade, but this time we're going to use a wet abrade. And the wet abrade, we're going to use some of the MPrep Conditioner A. That's a red tip bottle. This is a very mild phosphoric acid that's going to help to chemically clean and etch the surface of this aluminum. And we really combine two steps at this point. We're going to use that conditioner along with another piece of the 320 grit silicon carbide paper. What I like to do is tear about 1.5 inch long piece, take it and fold it back on itself, and then the same process like before, just abrade back and forth about 10 to 12 strokes. Right now, you're trying to lift off contamination, put it in suspension into the conditioner while the conditioner is also etching. You'll notice you got a lot of material left on the beam. So now you're going to take a gauze pad, fold it in half. I like to fold it in half again. And then start at one side of the cleaned area and use a single wipe through the gauging area. Now, we're going to do this process again, this time with 400 grit paper. So Ben's going to locate a piece of 400 grit paper, and again, the red tip bottle, the conditioner. Flood that area with conditioner, and then take another piece of the silicon carbide paper, this time 400 grit, and abrade back and forth about 10 to 12 strokes. We use 400 grit to give us a little bit nicer surface finish for the gauges to bond. And sometimes folks think that you want a perfectly smooth surface, and the reality is you don't. You want some texture for the adhesive to be able to bite to that surface. So once we abrade it with the 400 grit paper, then we're going to take a gauze pad, use a single wipe through the cleaned area, and at this point it's probably a good idea to go ahead and dry off the underside of the beam, and also discard the top couple of sheets of paper that have gotten wet from the conditioner. So just take off a couple of those sheets, toss them aside. Now what we need to do is we need to indicate a line of where the gauge is going to go. And for this exercise, we're going to use a 4H drafting pencil and a steel scale as a straight edge. So one of the things I want Ben to do is just to transfer the marks on the sides up to the top. So Ben, if you would, you can go ahead and take the scale off, but if you roll the beam to the side, you'll see the scribe marks on it. And in order to get those in the right spot, we want to transfer those up just like you're doing. Just put a small tick on each side. And then take the steel scale, lay it over top of it, use that as your straight edge. And now what you're doing now is you're trying to burnish this aluminum. The aluminum's soft enough that a 4H drafting pencil will actually burnish it. So he's going to use the steel scale as a straight edge, press down firm with the 4H pencil, go back and forth, hold that up so we can see it. And now all this black stuff that came off of the pencil is actually contamination, so we got to remove it. So at this point we need to locate our conditioner, and we also need some cotton tip applicators. Basically they look like Q-tips with a wooden handle. So what we're going to do, we're going to take the red tip bottle, the conditioner again. We're going to flood it right over top of that area that he just burnished, that black line. And now take the cotton tip applicator and scrub right along the axis of the line first to get rid of all the black stuff. And then once that's removed, then we'll scrub the rest of the surface. And sometimes the cotton tip wants to absorb some of the conditioner, so you may find that you need to discard it and get another one, and you may find that you need to add a little more conditioner as well. So as they turn black, discard it, get a fresh one, and also put a little more conditioner on it. So you scrub back and forth, just scrub the whole area where the gauges are going to be installed. I like to go a little bit bigger because you've also got an environmental coating that's going to be applied to the strain gauges, and you want all that surface area to be clean and ready to accept the strain gauge and the adhesive, but also that protective coating. Now, once you've scrubbed it, take another gauze pad, wipe it through the cleaned area. Sometimes we have to take it, refold it, and go the other direction, but you always want to wipe through the gauge area with a clean gauze pad. Now, once you've done that, we're ready to move on to the neutralizing. So we've burnished this line, we've scrubbed that area, now it's time to neutralize. We're going to take the blue tip bottle, we're going to flood it over top of the area, and take another cotton tip applicator and we're going to scrub. And at this point, everything should be pretty clean as far as the beam is concerned. If you see much black that starts coming up on the tip of that cotton tip applicator at this point, it probably means that you might have missed a step or two along the way. So scrub that, and then get another one if needed. Press down firm, give a good scrub. And then now we take another gauze pad, fold it, start inside the cleaned area, and maybe dry off the underside as well if needed. And let's go ahead and discard the top sheet or two of paper, because now the beam is ready. We got the beam ready to accept the strain gauge adhesive. So you can just take the beam and kind of maybe slide it to the side. And now we're going to work on our work surface, and we need to do a little bit of house cleaning. So what I want Ben to do is find your piece of glass just like you've done, and your blunt nose tweezers. These tweezers, we're going to use them to handle the strain gauges, and we want to make sure that the surface of the glass is cleaned as well as the blunt nose tweezers. And what he's going to use is a little bit of the neutralizer, the blue tip bottle, and put that into a gauze pad and use that to clean off the tips of the tweezers and also to clean off the surface of the glass. A little bit of house cleaning. Anything that comes in contact with strain gauge, you want to make sure it's clean. And we do go through a lot of gauze pads when we do this. Yeah, a few wipes back and forth across it. And the nice thing about, and this is really the reason why we use glass, is that it's non-porous. So you don't have to worry about something getting into it and leaching out later on. And also, you can easily tell if it's got something on it. You can pick it up and hold it in the light, and you'll be able to see if there's any contamination that's on the glass. Now, once we got the glass ready, and we're happy with it, now we're going to focus on handling the strain gauges. So it doesn't really matter which one we pick. What we're going to do is position these gauges out on the piece of glass, and then we're going to position them on the onto the beam. So Ben's going to show us which one he's got. This one is the
350 ohm.
350 ohm version. Again, they look about the same. You'd really have to look at them under a microscope to see the difference between the 350 and the 5000 because they are the same gauge size and construction. So we'll open the package up, go ahead and take the little folder out. I like to use the cleaned blunt nose tweezers. The gauges are actually inside of a little sleeve, and you can just kind of pull that little envelope out, kind of lay it onto the piece of glass, or you can lay it onto the clean sheet of paper, either way, and just take the rest of them and you can fold it back up and put that to the side. And then we'll go ahead and open up the other package of strain gauges as well. So these are the 350s, and this is where you got to be careful because, again, from the naked eye, they look about the same. So we'll go ahead and open up the 5000 ohm strain gauge package. Go ahead and get that seal off of it. And same thing, open it up and just remove one of those little envelopes that have the 5000 ohm gauges. Now, Ben's going to need to pick which side he's going to put these on. So we need to try to keep these straight. So as we look at them, these gauges look very, very similar. So the 350 are near the top, the 5000 ohm are near the bottom. Now, as we install them onto the beam, we're going to install them side by side. And the way that we have done this before is the 350 ohm gauge is going to be on the left-hand side, and the 5000 ohm strain gauge is on the right-hand side with the tabs facing down. So what Ben's going to do is orient the two gauges on the piece of glass and then use a piece of tape to pick them up. Now, as you start to handle the gauge, you want to handle it by the backing only. You really want to try to avoid touching the grid of the strain gauge. And take it and lay it out onto the piece of glass. So that's our 350. So we're going to lay that one to the left, and we're going to put the 5000 ohm gauge again with the tabs facing toward his chest. The 350 is on the left, and the 5000 is going to be on the right. And we're going to leave a little bit of a gap between them. It's not real critical at this point. We're going to leave a little bit of a gap between these two. And this is where, if you were working under some magnification, that can help. That can help you to get these aligned a little bit tighter. These gauges are essentially identical in terms of their overall footprint, so we can use that as a guide to position them. Yeah, I'd scooch them a little bit closer. And sometimes when you're doing this, it's easier if you go ahead and get tape over top of one gauge, and then you can get tape over top of the second gauge. And looking at it, sometimes the gauges, in particular in the winter months, they'll want to dance around on the piece of glass due to static electricity. If that's the case, then it's probably easier to handle them one at a time. I think here you're going to try to cover both with one piece of tape. So he's going to, now what Ben's using is this is the gauge installation tape. And what he's going to do is tear off a piece of it that's about, first off, he tears off a piece of it that's a couple inches long and throws that away because sometimes it can pick up some dust. And then he's going to take a piece that's about 3 or 4 inches long and tear it off. And now we're going to try to grab both of those gauges at the same time with the piece of tape. And the other thing he's doing, he folds the end of it over a little bit just to help him, kind of provides a little handle where it's not sticky as you touch it. So he's going to take that off. And now he's going to take the tape and apply it right over top of the two strain gauges. He's going to tack it down at one side and then wipe it down into place over top of the gauges. Now, once you've got the tape in place, that's your handle. That's your ability to be able to pick these gauges up, move them over to the part, get them in the right position, and then we can apply the adhesive. The tape is there as a tool to help us do that, and it also allows us to expose the bonding side of the strain gauge so that we can apply the adhesive. So he's going to reach over, grab the cleaned aluminum beam, and now what he's going to do is transfer the gauges off the glass onto the cleaned aluminum beam. Now, one of the things he's going to be careful of is he's going to lift the tape at a shallow angle. You don't want to go too steep because that can create a compressive offset in the gauge. And in general, we keep it less than about 45 degrees. But once he gets past the strain gauges, then he can go ahead and lift it on up. And now he's going to transfer it over to the burnished alignment mark that's on the beam. Again, same thing as before. You sort of tack it at one side and then wipe it down into place. Pick it up and look at it and see if you're happy with the alignment. If you're not happy with the alignment, you can pick it up and move it. Or if you're happy with it, leave it where it is. Now he's got the two strain gauges in place. Now we need to locate the adhesive. We're going to use the M-Bond 200. It's a quick setting cyanoacrylate. It consists of the adhesive as well as a catalyst. And the catalyst is there to help control the rate of the reaction. Again, this is the most common adhesive system we offer for stress analysis testing. So what Ben's going to do is he's going to go ahead and peel the tape back and expose the bonding side of the strain gauge and go back past that about another 1/2 inch or so. And then he's going to peel the tape back. And what we're doing is we're exposing the bonding side of the gauge so we can apply the catalyst and the adhesive. And then we're going to wipe it down into place and put our pressure on it. Now, when you're handling the catalyst, one of the most important things to recognize is less is more, meaning less catalyst is better than more catalyst because it takes longer to evaporate. So typically I recommend touching the inside of the inside portion of the bottle about 8 to 10 times, and then just use a single wipe on the back side of both gauges. If you can see that it's a real blue color once you apply it, you probably put it on too heavy. Now, as soon as you apply the catalyst, start your timer. We need to give it 1 minute in order for the solvent to air dry. The solvent is isopropyl alcohol. It takes about 1 minute for it to evaporate. Again, if you put it on heavy to where you can really see the blue, you probably need to wait a little bit longer. While we're waiting, I like to take a gauze pad and fold it in half and then fold it in half again. And we're going to use it sort of like a squeegee. once the catalyst is dry, we're going to put a drop of the adhesive, the Inbond 200, right at the junction of the tape to the surface of the beam. And I like to, if it's been a while since I've used it, I'll usually squeeze out the first few drops of the adhesive into the trash can, just because sometimes you get a little bit of adhesive that's stuck in that neck of the bottle. Making sure, I'm trying to make sure I get fresh adhesive from the main part of the bottle. And then put a drop right at the junction of the tape to the surface of the beam. As soon as you do that, and put the cap back on it. And you need to move quickly, and then take your tape, lift it back up, kind of pull it over towards you. Keep pulling it over towards you, and put a little tension on it, and then you can wipe the gauge down into place. And now get your thumb on it. You need to cover both gauges. And with Inbond 200, it requires 1 minute of thumb pressure. So again, you want to set your timer for a minute. Give yourself a full 60 seconds. Once we've gone that full 60 seconds, then we let it sit for an additional 2 minutes, and then you're ready to remove the tape and start adding the wires. This installation process, whether it's a 120, 350, or a 5,000 ohm strain gauge, is really the same. And that's one of the things we want to show you, that transitioning to a 5,000 ohm strain gauge from an installation standpoint really is effectively the same. So here we wait the 1 minute, and again we'll let it sit for another 2 minutes, and then we'll take the tape off. Okay, so we've waited our 2 minutes, and now we're ready to remove the tape. And this time, as you remove the tape, you want to peel it directly back on itself. You're trying to minimize how much force is pulling on the top of the strain gauge. And now the tape is off, and now we've got our 2 strain gauges positioned on that beam, and now is a good time for an optical inspection. Now you're looking at the strain gauges, make sure that they're in the right location, make sure that the gauge is fully bonded. You know, if you see any signs of voids or discoloration underneath the gauge, probably the best thing you could do is start over. And by starting over, I mean remove the gauge and do this process again. The last thing you want to do is rely on these measurements when you're not certain about it at this point. So at this point, when you look down at it, the gauges should look intimately bonded on the surface, no discoloration underneath. The entire gauge is bonded. If you have corners of the gauge that aren't bonded, the best thing you can do is start over again. So it looks like Ben is happy with these gauges. So at this point, we need now to focus on how to solder to them and get the wires ready, because we're going to attach some leads onto the strain gauge. So at this point, we're ready to bring in our soldering unit, and we need to let it start warming up, as well as the roll of solder, as well as the lead wire preparation as well.